Cosmic abysses. An introduction to black holes. Black holes are one of the most mysterious and intriguing phenomena in the universe. They captivate the imagination of scientists and the public alike, drawing us into their enigmatic depths. Black holes are among the most fascinating objects in the universe. They are formed when massive stars collapse under their own gravity at the end of their life cycles. This collapse results in a singularity, a point of infinite density, surrounded by an event horizon. Imagine a place where gravity is so strong that nothing, not even light, can escape. That's a black hole. The concept of a black hole challenges our understanding of physics and the nature of reality itself. The gravitational pull of a black hole is so intense that it warps the fabric of space-time, bending light and distorting the appearance of objects around it. These cosmic monsters are regions of space-time where gravity's pull is irresistible. The immense gravitational force of a black hole can pull in nearby stars, gas, and even entire solar systems. As matter is drawn towards the black hole, it forms an accretion disk, a swirling mass of gas and dust that heats up and emits powerful radiation. Black holes are not empty spaces. They are incredibly dense objects with enormous mass compressed into a tiny volume. This density is what gives black holes their extraordinary gravitational pull. The more massive the black hole, the stronger its gravitational field. They are incredibly dense objects with enormous mass compressed into a tiny volume. For example, a black hole with the mass of our Sun would have a diameter of just a few kilometers. This extreme density creates a gravitational field so strong that it can bend light and warp space-time. This density creates an incredibly strong gravitational field. The gravitational pull of a black hole is so powerful that it can capture anything that comes too close, including light. This is why black holes appear black. They do not emit any light of their own. The boundary of a black hole is called the event horizon. The event horizon marks the point beyond which nothing can escape the black hole's gravitational pull. It is often referred to as the point of no return. Once something crosses the event horizon, it can never come back out. This includes light, which is why black holes are invisible to us. The event horizon is a one-way boundary. Once crossed, all paths lead to the singularity at the center of the black hole. It's a point of no return, even for light itself. The gravitational pull within the event horizon is so strong that it overwhelms all other forces, pulling everything inexorably towards the singularity. Black holes are invisible to telescopes that detect light, X-rays, or other forms of electromagnetic radiation. However, we can infer their presence through their interactions with nearby matter. When a black hole pulls in gas and dust, the material heats up and emits X-rays, which we can detect with space-based telescopes. We can, however, detect their presence by observing their effects on nearby stars and gas. For instance, if a star orbits an invisible object and exhibits unusual motion, it may be orbiting a black hole. Additionally, the intense gravitational field of a black hole can cause gravitational lensing, bending the light from background objects and creating distorted or multiple images. The concept of black holes has a rich history in theoretical physics. The idea was first proposed by Jean Michel in 1783 and later by Pierre-Simon Laplace in 1796. However, it wasn't until the 20th century, with the advent of Einstein's theory of general relativity, that the modern understanding of black holes began to take shape. Carl Schwarzschild provided the first exact solution to Einstein's equations, describing a non-rotating black hole, now known as the Schwarzschild black hole. Today, black holes are a major area of research in astrophysics. Scientists use advanced telescopes in observatories such as the Event Horizon Telescope to study black holes and their effects on the surrounding universe. In 2019, the Event Horizon Telescope collaboration released the first ever image of a black hole, located in the galaxy M87, providing direct visual evidence of these enigmatic objects. Black holes can also merge with each other, creating even more massive black holes. These mergers produce gravitational waves, ripples in space-time that can be detected by observatories like LIGO and Virgo. The detection of gravitational waves has opened a new window into the study of black holes, allowing scientists to observe these events in unprecedented detail. The study of black holes also has profound implications for our understanding of fundamental physics. The extreme conditions near a black hole provide a natural laboratory for testing theories of gravity, quantum mechanics, and the nature of space-time. Researchers are particularly interested in the information paradox, a puzzle about what happens to information that falls into a black hole, and how it relates to the laws of quantum mechanics. Black holes have also captured the imagination of artists and writers, inspiring countless works of science fiction. From movies and TV shows to novels and video games, black holes are often depicted as gateways to other dimensions, time machines, or sources of immense power. While these portrayals are often speculative, they reflect the deep fascination and curiosity that black holes inspire in us. As our technology and understanding of the universe continue to advance, the study of black holes will undoubtedly yield new discoveries and insights. Future space missions and more powerful telescopes will allow us to probe deeper into the mysteries of black holes, shedding light on their origins, behavior, and impact on the cosmos. In conclusion, black holes are not just cosmic curiosities, they are fundamental to our understanding of the universe. They challenge our notions of space, time, and gravity, and they continue to be a source of wonder and inspiration. As we explore the depths of these cosmic abysses, we are reminded of the vastness and complexity of the universe and our quest to understand it. Thank you for joining us on this journey into the heart of black holes. Stay curious and keep exploring the wonders of the universe. Birth of a monster, the making of black holes. Black holes are one of the most fascinating and mysterious objects in the universe. They are regions of space where gravity is so strong that nothing, not even light, can escape from them. But how do these cosmic giants come into existence? Let's delve into the process of their formation. Black holes form when massive stars die. These stars, which are much larger than our sun, go through a life cycle that ultimately leads to their dramatic end. The journey of a star from birth to death is a tale of nuclear fusion, gravitational forces, and cosmic explosions. Let's break this down. Stars are giant balls of hot gas, primarily hydrogen and helium, powered by nuclear fusion in their cores. This fusion process involves the merging of lighter atomic nuclei to form heavier ones, releasing a tremendous amount of energy in the process. This energy is what makes stars shine so brightly in the night sky. This fusion creates outward pressure that balances the inward pull of gravity. In a stable star, these two forces are in equilibrium. The outward pressure from the fusion reactions counteracts the inward pull of gravity, keeping the star from collapsing in on itself. However, when a very massive star runs out of fuel, this balance is broken. Over millions or even billions of years, the star consumes its nuclear fuel, converting hydrogen into helium, and then into heavier elements like carbon and oxygen. Eventually, the star's core is left with iron, which cannot undergo fusion to produce energy. Without fusion, the star's core collapses under its own gravity. The outward pressure that once countered gravity disappears, and the core begins to shrink rapidly. This collapse happens in a matter of seconds, causing the core to become incredibly dense and hot. This collapse can trigger a supernova, a powerful explosion that blasts away the star's outer layers. The energy released in a supernova is so immense that it can outshine an entire galaxy for a brief period. The outer layers of the star are ejected into space, enriching the surrounding interstellar medium with heavy elements. If the core is massive enough, the collapse continues until it forms a black hole. The core's gravity becomes so strong that it warps space and time around it, creating a singularity, a point of infinite density. The boundary around this singularity is known as the event horizon, beyond which nothing can escape. There are two main types of black hole formation, stellar and supermassive. Stellar black holes are formed from the remnants of massive stars, while supermassive black holes are found at the centers of galaxies and have masses millions or even billions of times that of our sun. Stellar black holes form from the death of single, very massive stars. When these stars exhaust their nuclear fuel, their cores collapse, leading to the formation of a black hole. These black holes typically have masses ranging from a few to several tens of times that of our sun. Supermassive black holes, on the other hand, are found at the centers of most galaxies and are millions or even billions of times more massive than our sun. These colossal black holes have a significant influence on the formation and evolution of galaxies. How they form is still a mystery. Scientists have proposed several theories, including the collapse of massive gas clouds in the early universe, the merging of smaller black holes, and the accretion of vast amounts of matter over time. However, the exact process remains one of the biggest questions in astrophysics. The formation of supermassive black holes is thought to be closely linked to the early stages of galaxy formation. In the early universe, dense regions of gas and dust began to collapse under their own gravity, forming the first stars and galaxies. Some of these regions may have been massive enough to form black holes directly. Another possibility is that supermassive black holes grew through the merging of smaller black holes. When galaxies collide, their central black holes can merge, creating a larger black hole. These mergers release gravitational waves, ripples in the fabric of space-time that have been detected by observatories like LIGO. Accretion of matter is also a key factor in the growth of black holes. As matter falls into a black hole, it forms an accretion disk, a swirling mass of gas and dust that heats up and emits energy. This process can cause the black hole to grow significantly over time. Some black holes are incredibly active, emitting powerful jets of energy that can be observed across vast distances. These active black holes, known as quasars, are among the brightest objects in the universe and provide valuable insights into the behavior of black holes and their impact on their surroundings. To better understand black hole formation, scientists use computer simulations and theoretical models. These tools allow researchers to explore different scenarios and test their hypotheses about how black holes form and evolve. By comparing these models with observations, scientists can refine their understanding of these enigmatic objects. Future advancements in technology will also play a crucial role in unraveling the mysteries of black holes. New telescopes in space observatories, such as the James Webb Space Telescope, will provide unprecedented views of the universe, allowing scientists to study black holes in greater detail than ever before. The study of black holes is an ongoing and collaborative effort. Scientists around the world are working together to uncover the secrets of these fascinating objects. Each new discovery brings us one step closer to understanding the true nature of black holes and their role in the cosmos. Black holes are not just cosmic monsters, they are also key players in the story of our universe. From the death of massive stars to the formation of galaxies, black holes have shaped the cosmos in profound ways. As we continue to explore the universe, we will undoubtedly uncover even more about these incredible objects and their place in the grand tapestry of space and time.